Our next talk is by my co-chair, Yaeji Kim, and the sensitivity of 99942 Apophis Nect to resurfacing during the 2029 Earth flyby. And so whenever you choose to start, go for it.
Okay. Dr. Faith, can you see my screen?
Yes, I can. I can hear you too.
Okay. Thank you so much for introducing my talk. My name is Yaeji Kim, and I'm working with Dr. Masatoshi Hirabayashi at Auburn University. So the previous speaker, Dr. Umberto, will introduce about Apophis and its 2029 Earth encounter. So I'm just gonna start with the motivation of our study. Apophis is planning to approach the Earth around the 6 Earth radius, which is the outside of the Roche limit. As you know, the Roche limit is the maximum distance that a small body can be separated into several fragments due to the tidal force of another celestial body. So assuming that Apophis density is around 2 grams per centimeter cubed, based on this equation, Apophis Roche limit is a 3.4 Earth radius.
Yaeji, I lost your voice. I don't know if others have.
Oh, could you hear me?
Yeah, I can hear you. This is Christina. Faith, can you hear me?
Oh, yes.
Well, I think Faith may have lost signal. Go ahead and continue.
Okay. Yep, so the Apophis Roche limit is estimated 3.4 Earth radius, which is lesser than the Apophis closest distance. So based on this, we expect that Apophis will experience small changes, such as the movement of surface particles or small changes in its internal structure during this encounter. So here are some earlier works that prove our expectations. These are saying that Apophis will experience spin changes during its flyby. It may also have tiny landslides at some locations or possible seismic waves inside of Apophis. So we believe that this encounter event would give us an amazing chance to observe the possible consequences of tidal stress directly, which is a non-catastrophic level. So a well-understanding of Apophis behavior earlier than this event would be necessary for any possible missions targeting Apophis. Also, a well-understanding of this asteroid at this encounter time would be eventually helpful in proposing suitable guidances for planetary defense technology. So I'm going to introduce 2 numerical models that we are using to analyze Apophis when it is impacted by the tidal effect. So the first model, it is called by dynamic model. It is developed to see how the surface of Apophis is evolved during its flyby and eventually provide us reasonable locations that may be susceptible to material flows. So the encounter event is modeled as a 2-body problem. So the Earth is assumed as a sphere, while the current radar shape model is used for modeling the Apophis. This current radar shape model hints that the Apophis probably has a contact binary shape. So these are entire equations of 2-body problem that we implemented in our numerical simulation package. So the acceleration acting on each element is computed by self-gravity, gravitational interaction force from the Earth, and the rotational force. So for this, the Apophis trajectory and its spin state are updated. So for the trajectory, we imported its orbital information from the JPL Horizon Web Interface into our model. Also, we are using Euler equations to integrate the spin state of Apophis. The initial spin period here is fixed 30.6 hours, but the spin orientation of Apophis is still an uncertain parameter here. So using Monte Carlo simulation, we conducted multiple simulation cases depending on different initial spin orientation. And the last step is to convert this last step is converting this acceleration data into a surface slope that is technically describing how the surface element is tilted on the direction of the affected gravity. So based on the conventional theory of the angle of repose, we assumed that material flows may occur when this surface slope exceeds the angle of repose. So we simply compare this parameter with the angle of repose to estimate which locations would be sensitive to material flows. In the second model, we are using the finite element model, which named FEM, to investigate how Apophis structure is impacted by the tidal force. So FEM eventually provide us which locations would be failed during the encounter time. In this model, Apophis is considered as a continuum that has soil characteristics. And then to obtain the elastic and plastic FEM solution, we used the commercial software ANSYS Academic APDL. And the plastic solution, the yield condition of Apophis is defined by the Drucker-Plager yield criterion here. And then using this model, we perform two numerical cases. One case is when Apophis is not affected by tidal force, but only influenced by gravitational and rotational force. Another case is when it is affected by tidal force as well. So in the following result section, we're going to compare those two cases and see how the structurally failed reasons can be changed due to the tidal force. One thing I want to point out here is that our current FEM only considers a static case, which means it is ignoring the time evolving effect. So the magnitude of the tidal force applied here is only fixed at the closest flyby. So our research show one case from the dynamic model. This upper figure shows the maximum surface slope at each element, and the bottom figure shows the slope variations during the encounter. As we can see here, the slope variation reaches up to 2 degrees, which is not enough to significantly change the initial distribution of surface slope. So for example, this blue region here, I will use eraser. So this blue region here won't become the unstable even if this location has the maximum surface slope variation like 2 degrees. So in this tidal encounter, we can say that the possible resurfaced region or susceptible locations to material flows would be around the initially high sloped region, which means it is highly likely to depend on the shape of Apophis. In our further analysis, we divided the Apophis shape into 3 locations: small lobe, large lobe, and Nect regions, because it is a contact binary shape, and then see how the size of possible resurfaced region and slope variations changed at each location. When we look at the left figure first, the y-axis means the size of the possible resurfaced region, while the x-axis shows the case numbers. So this result tells us that only tiny regions would become unstable because it is only 1.5% of the entire region at all cases. When we separate this data into 3 different locations, then the large lobe have the largest portion of the resurfaced region, and then the Nect region also has some portion of this region. This is because the initially high sloped regions are distributed in the large lobe and the Nect regions in our current radar shape model. So and then in right figure, it looks a little bit complicated, but this figure eventually wants to say that the distribution of surface slope variation would be changed depending on Apophis spin orientation. Because at some cases, the maximum slope variation happens at the large lobe, but at other cases, it happens at the Nect or small lobe. So the slope variation can be dependent on the orientation spin, the spin orientation of Apophis. But as I mentioned before, the slope variation maximum 2 degrees is still weak to significantly change the location of resurfaced region, even if the slope variation is strongly affected by the Apophis spin state, Apophis spin orientation. In this tidal environment, our FEM results indicate which locations would be structurally sensitive. So when we compare those two cases, one is before the encounter, another one is at the closest to flyby, we can notice that only Nect regions have an increase in failed regions. This is because the Nect region in a contact binary shape is structurally weak because of its lower self-gravity than any other regions. Also, we noticed that if we want to observe the failed regions around the Nect, the cohesive strength should be very weak. So our model estimates around 0.3 Pascal, which is very weak because failed regions. So from our analysis, the expected tidal force during the 2029 is very weak to cause significant or observable changes on surface or structure of Apophis, although we noticed small changes. However, we still have further work to investigate Apophis under this tidal effect condition. First, we're going to obtain the new radar model through the observations in 2021. So this is going to give more accurate estimation of resurfacing regions. Also, as I mentioned before, our FEM only considered a static case. So it is going to be ignoring time absorbing effect. So we are planning to expand this model to apply a dynamic case and expect see more noticeable changes from the advanced model. So I'm going to finish my talk here. I appreciate your attention.